Hello! So today we are going to have a look at programming a flight plan into the Vision Jet and doing a quick flight around Stansted Airport and coming in on the ILS and doing a landing. So we'll have a look at ILS approaches, we'll have a look at following waypoints with a GPS flight plan, and we'll look at VORs as well. And we'll just go for a fly basically, but with a heavy emphasis on looking at how these various systems work within the aircraft. Okay, let's go and have a look at Little Navmap first, just to see what we have got programmed in. So if I come and pull up the details for Stansted on Little Navmap, you can see the wind today is 190 degrees, 3 knots, so it's coming from the south at 3 knots, which is nothing to worry about. We're going to fly out to the southwest, runway 22 at Stansted, out to the waypoint Ekvej, then over to Oduku, then Brain, Abbott, Totsvo, and then back in on the ILS into runway 22. So, along the way we'll have a play with looking at some of the VORs. We'll probably use this one down here on the southern leg, the LAM VOR, so maybe we'll fly a radial from it over to Brain or something like that. So just for when we get there, for some reference, let's go and draw that line in so we can see it. So from the LAM 115 VOR 115.6, 62 degree radial, 21 miles over to Brain. So we'll try it and we'll see how it goes. But before we get going, let's go and program that basic route into the flight plan on the Vision Jet. So to program a flight plan, you come down to the screen down here and you click on, if it isn't showing the home screen, just click the MFD soft key alongside the display and it will show this. So then you can click on flight plan and you can add the origin. So in our case the origin is EGSS, which comes up with an instant lookup of Stansted, which is correct. Press enter and so it updates to show the origin, and you get the details of the airfield there. We're going to set the destination as EGSS, Stansted. Enter. So we're going from Stansted to Stansted. So now we can put the waypoints in between. So our first waypoint is Ekvej. So add en route waypoint EKVEG, Ekvej, and it knows it's in the United Kingdom, which is correct. Add the next en route waypoint after Ekvej will be Oduku. Oduku, United Kingdom, correct. So we've got Ekvej, then Udoku. You can use this little scroll bar here to move up and down. Add another en route waypoint and we can go for Brain. So BRAIN. And it again is saying this time there are duplicates, there are other ones called Brain. So when we press enter, it will show us the ones it's talking about. We know we want the one in the UK, so we'll select it. So we've got Oduku, then Brain. Then we want Abbott. So add waypoint ABBOT. And it knows that's the only one. And our final en route waypoint is Totsvo. Add waypoint TOTV. And it's in the UK, which is correct. So now we've got our basic waypoints, okay, between Stansted and Stansted. Now if we didn't want to do this flight plan at all, we can go into flight plan options and we can delete the entire flight plan. Okay, so if we messed up in the programming of this, we could easily go and just delete the entire flight plan and start over again, but we don't have to. And again, if you wanted to put some altitudes in along the way, you could, and that would allow you to then use the vertical navigation button over here. We're not going to, we're just going to fly fairly manually around this route. Actually, it's worth pointing out, if we wanted to, we could program procedures. So to program a procedure, by a procedure I mean either a standard instrument departure or a standard approach route. If we wanted to do procedures, we could then click the procedures button and it pops open asking us for the departure of the arrival and the approach. So for departures I could, for example, say I want to do the BKY5R departure from Stansted from runway 22, and I just click load and it will put those waypoints directly into the flight plan for me. If I wanted to choose an arrival, for example, into Stansted, I could choose one of the many arrivals and the runway I want, and again load, and it would appear. And the same goes for approach. Notice with approach you get activate. Activate really means preset it so the radio frequencies will be ready for the ILS and all that kind of thing. So let's go back though and have a look. So we've got just a waypoint to waypoint flight plan programmed in, which is absolutely fine. We can have a standby flight plan as well if we want. We're not going to bother. So, and notice you can activate the standby. Anyway, let's come back out. So runway 22 is 222 degrees on the compass, but we've got a flight plan which you can now see, by the way. And if we use the knob at the bottom right of the MFD, the multifunction display, we can zoom in. You will notice the next leg is in magenta, so that will update as we fly around the flight plan, showing what the next leg is all the way. Okay, let's go and try it out. Oh, it's worth pointing out before we get started, if you want to switch between using GPS and VOR as you are flying along, what you have to do is go to the PFD, the primary flight display, and you can choose your nav source on the PFD. Yeah, so if you're somewhere deep in the menus in here and you've been looking around seeing what you can configure, and you think, oh, I'm hopelessly lost now, like for example, you can turn on the view of terrain and things like that in the map view, on the inset map view. We're not going to bother with all of that, but say you are in one of these screens and you're thinking, oh, how do I get back to go and change the nav source quickly? You just press the home key, yeah, and then nav source is top left. So you can see as you click on it, it cycles between nav 1, nav 2 and GPS. And you can see there's a symbology difference there. So GPS is magenta, nav 1 is a green solid line, nav 2 is an empty solid line. So you can see at a glance which radio you are actually using. Okay, so we're going to use GPS. Let's go and get the aircraft fired up then. So generators on, landing lights on, oxygen's already on, propheat's already on. It's pretty freezing outside. A bit of a handy tip, to find out the outside air temperature, it's not readily available. If you look across the top of the MFD, it doesn't actually tell you the outside air temperature. So what you can do is go to Aircraft Systems on the MFD menu screen, and you can pull up the ice protection screen, and at the top of the ice protection screen it tells you the outside air temperature. Okay, that's worth knowing about. Notice there's also the option here to go full, and it doesn't always work. So if we come back out of there and just press the MFD key, yeah, it's not going to work. Look, home. It's not going to get rid of ice protection now. So if I go back into, that's a bug, by the way. We should be able to move the focus. There we go. So the roller on the top right. There we go. As soon as we move this roller, we can select which one of these we want to be full. That makes more sense. Okay. Let's go and get this flight done anyway, just so you can see how the autopilot works as well. So come off the parking brake. Flaps to takeoff position, which is 50% I think in this aircraft. So we've got fuel control is auto. The flap lever is down here. So if we look closely at it, so it's actually just got speed ratings for the various flap levels. So 50% it wants 190 knots. Oh, well, that's the maximum, 190 knots. 150 knots for full flaps. Okay, so let's go and roll out to the runway. As we roll out to the runway, let's have a think about the altitude we're going to be flying at. So to set that, you'll see the target altitude is at the top of the altitude ribbon. on the primary flight display. So if you roll the altitude knob, this is the master control panel for the autopilot, by the way. So if you roll the altitude, you'll see the number changing up here. So we'll go and set it for 5,000 feet. There we go, 5,000 feet. We're going to press B as well to calibrate the altimeter, so you can see the numbers changing here. So we're now showing an accurate altitude above sea level, at ground level at the airport. Okay, so we've set that. We'll worry about the rest once we're in the air. Something else you can do, which is quite useful, is to set the heading bug, which you can see it just moving around the edge outside of the compass here. Set the heading bug to the runway direction. Oops, I'm just trying to do two things at once here. So there's 2 degrees on the heading bug, and we're just going to roll out to the runway. We don't need the whole runway in this aircraft. So there are 2 parallel taxiways at Stansted, which is quite helpful. So if we sit up, we'll be able to see the taxiway going out towards the runway easily. So then do a right turn here. So when we first engage the autopilot, it will be... Actually, let's come to a halt here, just so we can explain this before we get going. So back on the parking brake, engine's back to idle. So if you notice, the panel above the primary flight display tells you what autopilot modes you have engaged. So while we're on the ground, we can actually engage heading mode. And remember, we've got it set to the runway direction, which is 222 degrees. We could go straight for nav mode, but it won't engage it straight away. And then we've got the altitude. We put our target altitude in, and how are we going to get there? We could say flight level change mode to get there. So let's see what happens though. It may counteract that when we engage the autopilot. So it'll be interesting to watch that happen. So let's come back off the parking brake, roll out to runway 22. So it's interesting to see these kind of edge behaviours of the various different avionics systems in the aeroplanes, to see how they behave when they're just being engaged, you know, and they've already been configured. What settings will they hold on to? Which ones will they reset at the point you engage them? Okay, so if you can hear voices in the background, please ignore them. Okay, so we'll hold the centre line and full thrust, which will come up with the takeoff thrust enunciator down here. So we get to about 100 knots and rotate, and it comes off the ground straight away. Gear up. It's an enormous runway at Stansted. We don't need any of it really. It flaps up, and trimming the aircraft for climbing, and then as it picks up speed, obviously it gains more lift, so we're trimming back nose down again. And let's go for autopilot on, and you will notice, okay, so what has it actually done? It's going for the flight level change straight away, and it's holding GPS straight away, so we didn't have to intervene in any way. So it's climbing at, it's picked 150 knots seemingly to do the flight level change. So I should probably explain that. Flight level change means the aircraft will use, within its own knowledge of its capabilities, will do its best to get to the altitude you have selected as quickly as it can. There are other ways of doing this. So we could go for vertical speed mode, for example, and then we can set the speed. So if we went for 1,000 feet a minute, there's the actual vertical speed. So it's just settling down, and obviously you can see we are accelerating. So it will carry on accelerating. if we could go for 2,000 feet a minute, and it's just about accelerating still. But just as equally, we could go for 4,000 feet a minute to get there. Yeah, so I've set 4,000 on vertical speed mode. On the climb out, oh, it's already coming up to the target altitude, so it's leveling out. But the point I'm making here is vertical speed mode means you can select a vertical speed that the aircraft cannot sustain. Yeah. Okay, so we are coming up towards Ekvej in a moment. We've already got to 5,000 feet, so that's quite good that we've already got there. So the other thing we can do in the Vision Jet is use the automatic throttle. So if we engage it, it lights up, and you get a target airspeed on the based on the FMS. So it's gone for 250 knots, but because we're below 10,000 feet. But we can actually go to manual, and we can set whatever target airspeed we want. So we could say 240 knots. So you'll notice the target airspeed you set with this roller appears at the top of the indicated airspeed ribbon. Okay, so we've hit the target altitude. Look, the aircraft has switched over to altitude hold mode automatically. And that's indicated over here as well on the master control panel for the autopilot as well. It's still on nav mode, which means it's following the CDI mode, so GPS. So we're just coming up to Ekvej. Let's go and have a look though and say we were going to say when we got to Ekvej, why don't we fly for this VOR 115.60. So let's, while it's making the turn, let's go and have a look at doing that, shall we? So to do that, we need to go into the radio frequencies. And they are over here. You will notice they're on the navcom section, so you can get to them on all three screens. So if you go to navcom, you go to radios, nav 1 is here, so if we click on the frequency for nav 1, we could say 115.60. So 11560. Okay, and then we can press transfer to make it the active frequency immediately. So that won't make much difference at the moment, but say we go and put 62 degrees into our heading. So if we go and spin that heading bug around, we're going to have to go nearly all the way around to get to it. So we're going to do the radial from the VOR, so that's 62 degrees. We'll go to heading mode on the autopilot. So the aircraft is now going to disregard the flight plan and turn left to 62 degrees, which you can see happening over on the map over here. So now that's happening, now it's flying on heading mode, we can safely change the mode on the primary flight display of the nav source. So we'll go and change that now to nav 1. So you can see we need to actually change the course though. So the way to do that in the Vision Jet, because there's no button to do it, is hold Control Shift down on the keyboard and use the home and end keys. So we need the course to be 62 degrees. So I'm just spinning the course round to 62 degrees. So you can see we are to the left of the 62 degree track from the VOR. So from means this little green arrow is pointing behind us. It means the VOR we are tuned into is actually behind us. Yeah, which is true, look. There's the VOR, there's us. And we are to the left of the track. If we go back to nav mode now, the aircraft will crab sideways onto the 62 degree track. But you have to have set your course for this to behave in this way. In many ways, the radio navigation is more advanced than GPS navigation, because you can do these games like flying at a particular angle into or away from a VOR station, whereas with GPS you just select more and more waypoints, yeah, and add them into your plan. So you can see, because we have actually gone past that waypoint, the next segment has lit up automatically. So if we wanted to, I mean, we are doing what we're doing, we would fly straight towards Brain. and it's not a problem. So we're flying the 62-degree track. You can see it happening here, look. The aircraft is centering up on the 62-degree line completely automatically by following the radio beacon from the VOR. But what we could do at this point, just to show this is possible, we'll go and turn the heading round to the direction we're going again. So we'll go back to heading mode. The reason we use heading mode is so we can change this mode over with nothing reacting. Okay, so we can come back in here, change the nav source to GPS. So you can see here the details come up for the GPS, and we can say go back to nav mode, and the aircraft will bank right. It's going back towards this line. Yeah? See, at the moment this has gotten a real mess, but if we go and put in brain and right click and activate the flight plan leg, we can see, you know, much more visually what's going on. So we're on this leg and we are doglegging across to get to the original flight plan line for brain, but we're doing it under nav mode. So the airplane's doing it automatically, and here comes the course deviation indicator. So this line here that's sweeping in, that is the CDI, or the course deviation indicator. The entire gauge is the HSI, or horizontal situation indicator. You get some really nice information here. So you can see we are 6.1 miles away from the waypoint. So we're flying in towards brain. It gives you ETE, which is estimated time en route. So it's your time to the next waypoint. You also get a lot of information across the top of the map display. So you've got ETA, so that's to your destination. You've got the bearing, ETE, the en route. You've got the track. It's very good. Okay, we're ripping along here at full throttle, so I'm going to cut the throttle back. Oh, actually, there's no point, is there? I'm on automatic throttle, I'm not on full throttle. So that gives you a good indication, actually. One of the problems of using this simulator with physical controls on your desk is if you're using an automatic throttle, you will have a disparity between where the throttle actually is in the aircraft and where yours is on the desk, which is what I just did and made a mistake with that. Okay, so we will make a left turn very soon for Abbott. You can see brain to Abbott is already lit up here. So it's already gone magenta and it's giving us the details here. So we've got 13 miles to go to Abbott. So this actually transfers before you get there. Okay, we need to drop down to about 2,800 feet. So let's go and drop our target altitude to 2,800 feet and do a vertical speed to get there. So we'll come down at 1,500 feet a minute. Now watch the throttle. Can you see the throttle pulling back all on its own? That's because we have selected we want to try and stay at 240 knots, and notice it is lagging. It's not managing to do it very easily. So you really do need to keep an eye on it when you're doing this kind of thing, and use the air brakes to help if you need to. Or spoilers, flaps, whatever you've got. It depends what speed realm you're within. So you will remember looking at the flaps, they have a maximum speed, so you can't use 50% flaps until 190 knots. We're doing 240, so we can't drop them yet. So what you might want to do, I mean, we're quite a long way out still, but we might want to start pulling back that speed. And that might impact our descent. It will usually prefer to change your speed over your altitude. So it's not going to be descending potentially at the rate you've asked for if you've gone for a slower speed. So we'll go back for 180 knots. and we're just coming down to 2,800 feet. The reason I have said 2,800 feet is if you go and look at the information on Stansted, it's got an elevation of nearly 400 feet. Yeah? So altitude is measured above sea level. We ideally want to be at 2,500 feet when we come into the feathers, to be below the ILS, below the beam, otherwise we can't capture it. Yeah? So when we turn the corner at top vote and come in, by making sure we are at about 2,800 feet, we know we are going to be underneath the ILS, which is 2,500 feet above ground level. Yeah? So a 3-degree ILS tends to be about 2,500 feet at 8 or 9 miles out. So that, therefore, we can make sure we are underneath it as we come into it. We'll be flying straight and level, but we'll meet the beam as it climbs from the ground in this area. So we'll hopefully see that happen. And again, we need to go and, therefore, while we're flying around on the approach, we'll go and program in the ILS. So it's 110.50 and 222 degrees on the course. So we go to the Navcom section, radios, and we want 110.50. So Nav1, 110, it was already on there, wasn't it? 50, and we transfer it. Okay, so you can now see the ILS frequency is programmed in, and we can come back out of here. We can go back to the PFD screen. Notice at the moment though it's just showing GPS. So when we come through TopVo, we'll switch away from GPS, but we'll get our heading bug ready for nav mode on the way out of there. So we're kind of using all of the things, all of the facilities available to us to allow us to change modes and do what we want without any surprises. So we're staying one step ahead of the aeroplane if we possibly can. So 2 degrees. Okay. It's absolutely freezing cold in the UK this weekend. That's why you can see this freezing mist hanging over the ground. There's not any clouds around. It's just cold. So if we go and have a look on here, it'd be interesting. There's not much. There's no clouds, so you've got not much worry of icing. But it's not fun. If we go and have a look on that aircraft systems page, pull up ice protection, we can see there's -1, -2. So if you remember, to be able to get rid of this, what we need to do is switch the focus. No. I'm trying to remember how I did it now. There we go. It's this one. So you roll the outer ring if you've got multiple panels displayed. You get the focus back on the left-hand one, and then you can say full, and it will make it go back to full. Okay, so we're turning back towards the runway, so we can go for heading mode now. Now we're on heading mode, we can change the source without worrying about the aircraft lurching around. So there's our localizer, and we're below the glide slope at the moment. So let's go for nav mode. Okay. And the glide slope is starting to slide down. Yeah, you see we're getting closer to the point I said we would need to be below the glide slope to capture it for the beginning of the feather. So we're already in nav mode, so we're tracking the localizer. If we go and engage approach mode, yeah, so that's the button here. So rather than doing nav mode on its own, which is just our lateral position, it's also going to take notice of the glide slope. So we're going to start slowing down and start dropping the flaps. So let's go for 160 knots. Flaps go to 50%. Gear can come down. And if we look out in front of us, you should see... Oh, also notice, look, we have... The glide slope is now in the middle, so we've flown into it and the aircraft is descending and following it. The localizer is also very nearly in the middle now, so we should be able to, quite safely, go and sit outside and watch the approach. Except there's an aircraft in our way, but we'll take no notice of them. Hopefully they'll be gone by the time we get there. So normally on approach you would be looking to decelerate further, so we'll come down to 120 knots for this aircraft. Once we get below 150, remember, we can go for full flaps, which I'm just about to do. So we are following the 3-degree glide slope down. We've got radar altitude now, or radio altitude I should say. And the aircraft is flying its own approach. In the real world, you would not do an auto land. So we will get to a decision height which will be several hundred feet, and then we would disengage the ILS. So I'm going to do it a little bit earlier. So auto throttle comes off. So I'm now using the throttle myself.
Don't sink. Don't sink.
So I'm going to turn off the autopilot at this point and
sink.
fly in.
Don't sink. Don't sink. Don't sink. Don't sink. Don't
That's quite
sink.
funny that it's doing that, isn't it?
Don't sink.
It's noticing the
Don't
trees, I
sink.
guess, on the terrain
Don't sink.
system.
Don't sink.
The TORS system.
Don't sink. Don't sink. Don't
So all we're
sink.
doing is watching the
Don't
diamond
sink.
here. So if we
Don't
lift
sink.
our nose, it will
Don't
drop, see?
sink.
And if
Don't
we dive
sink.
the nose, it will come
Don't
back.
sink. Don't
Same
sink.
is true for the
Don't
localizer.
sink.
So we can weave
Don't
either
sink.
side, and it will
Don't
weave
sink.
either side of the aircraft.
Don't
Yeah, so
sink.
we're off to the left.
Don't
Obviously
sink.
we're off to the left.
Don't sink. Don't sink.
So we can get back
Don't sink. Don't sink.
fairly near, fairly
Don't
quickly.
sink. Don't sink. Don't
That's
sink.
funny that TORS is doing that,
Don't
isn't it?
sink. Don't
There's a few
sink.
bugs in it, I think.
Don't sink. Don't sink. Don't sink.
It's an enormous runway. We have loads and loads of room here to land nice and smoothly. And we're down. Didn't even scratch the tyres. Okay, so flaps up and we can roll along. We've got a lot of runway. No need to worry about stopping quickly. And there's high-speed exits on big runways usually. There's one coming up in a moment. So if we sit up, you'll be able to see that high-speed exit coming. Yeah, here it comes, look. So yeah, hopefully showing you all those different modes and how you can interoperate between them, of, you know, reverting to heading mode and GPS mode, and then localizer or nav mode using the radios. You just naturally switch between them during the flight, really. And obviously while you're en route you might be using GPS all the time, but obviously once you get onto finals you'll be switching over to radio, so you probably want to get your heading ready beforehand, so you can, in the interim, have heading mode on while you sort the ILS out. Otherwise the worry always is that if you haven't sorted out your course and heading and everything else, when you're switching modes on the autopilot, the aeroplane might start banking around doing something you weren't expecting. So if you're ahead of the game in terms of pre-programming everything, so by the time the autopilot sees what you've configured, it's already what you meant it to be, rather than you chasing the aircraft, which ends up being bit of a disaster. Anyway, I'm not going to taxi all the way back. Today was just to show you programming a route and then playing around with the autopilot master control panel to do an approach. Obviously we could have programmed the route using procedures like standard instrument departure, but all they really are sequences of pre-programmed waypoints. So we looked at programming waypoints by hand. All a SID or a star does is programs a whole bunch of them for you in one go. Anyway, I'm going to leave it there, and I'll see you again soon. Okay, take care.